Determine if a function has an inverse. As the name implies, an inverse function will undo what the function does. If f of x is a function, the inverse of the function f of x is denoted by putting a superscript of -1 after the function name. So this doesn't mean that you're raising it to the -1 power. This is just a notation for the inverse of a function f of x. So here's an illustration of a function and what its inverse will do. So if you put apples into a function f and you get lemons out of the function, then if we take that output of f and now it becomes the input of the inverse, well, the output of the inverse takes you exactly back to where you started. Okay, so that's what it means to say that the inverse of a function is going to do the opposite or undoes what the original function did. So if you put x into a function, then you get f of x as the output, right? So let's say that we have our function machine f. And if we put x into that function, the output, or the y value, is denoted f of x. So now, if you take the output of f and make it the input of its inverse, so if I put the inverse below, so now f of x is the output of the original function. So now I'm going to make that the input of my inverse. That means that the output should be what we originally started with. Okay, so if you take the output of f and make it the input of f inverse, then the output of f inverse will be x, the input of f. Okay, so this is more concisely stated in the next rule. If f and g are inverse functions, then if I put one of the outputs into the other, so if I find f of g of x, that's going to give me x, my original input. And if I find g of f of x, that too is going to take me back to where I started, and that will equal x. Okay, so both of these things have to be true for those two functions to be inverses of each other. So in the next example, determine if the following pairs of functions are inverses. So in part A, the first thing I need to do is find f of g of x. So first thing we need to do is substitute what g of x is equal to in the innermost parentheses. Well, that's 3 over x. So now this means that I'm going to take the 3 over x, plug it into my function f everywhere I see an x. So this is going to equal 3 times 3 over x. Okay, well notice the 3's don't cancel. 3 is the same as 3 over 1. So we end up with 9 over x. Now since this does not equal x, that tells me that these are not inverses, because the rule above told us that that composition should equal x if they are inverses. Okay, looking at part B, to figure out if this f and g are inverses, we need to find the composition. So we're going to plug the g of x in, so 1/2 x minus 1. So everywhere I see an x in my original function f, I'm going to put all of that in its place. So we end up with 2. Instead of just x, we now have 1/2 x minus 1, and then bring down that plus 1. So now you need to make sure to distribute the 2 to both terms. 2 times 1/2 is just a 1x. 2 times negative 1 is negative 2. We still have the plus 1 on the end. So it looks like we end up with an x minus 1. So since this does not equal x, we can stop and we can say that these are not inverses. If we did come up with x for our answer, then we would just also need to figure out what does g of f of x equal. Make sure that that also equals x, and then you can conclude that the two functions are inverses. Okay, and a rule to keep in mind is that only one-to-one functions have inverses that are also functions. If a function is not one-to-one, then the inverse will not be a function. It'll fail the vertical line test. So the last thing that we want to look at today is how to find the inverse of a function. And there are 3 steps that you're going to follow. First, change the function notation back to the variable y. Secondly, interchange the x and y variables. Last, solve for y. This will be the inverse function. So if we start with part A, I'm first changing my f of x to a y, so y equals 3x minus 2. Now I need to interchange my variables. So now I have x is equal to 3y minus 2, and now I need to solve for y. So we add 2 to both sides to get x plus 2 is equal to 3y. Last step, divide both sides by 3. And we get that y is equal to x plus 2 over 3. So since we have the y by itself, that means that that's our inverse function. And since f was the original function, we denote the inverse with our little superscript of negative 1. Okay, let's go to part B. First step, we need to write a y instead of the f of x. Our next step, we need to interchange the x and the y. And then our last step, we need to get the y by itself. So I need to add 7 to both sides. So x plus 7 equals y cubed. And so now, what is the opposite of cubing something? Taking the cube root. So y is going to equal the cube root of x plus 7. And now since we have y by itself, that means that that's our inverse function. So we started with an f of x. It looks like we called all of these f of x, so the inverse is f inverse of x equals the cube root of x plus 7. And that's our answer. Okay, going on to our last one. Okay, we start by putting the y in place of f of x. And now I need to interchange my x and my y variables. So x equals y minus 2 over y plus 1. So now I need to solve for y. So I'm going to multiply both sides by my least common denominator, which is my only denominator, y plus 1. So when I do that, on the left, we're going to have to distribute that x to both of the terms inside of our parentheses. So we end up with x times y plus 1 times x is just x, is equal to, okay, on the right-hand side, the y plus 1's cancel out, leaving us with a y minus 2. So now I need to get all the y's, everything that has a y on one side, and everything else on the other side. So we keep the xy. I'm going to subtract over this y, equals, I'm going to bring the x to the other side so it becomes a negative x minus 2. Okay, well the last thing we need to do is to factor out a y. Notice that's a common factor. So if we factor out a y, we're left with x, bring down the minus. Well, what do you have to multiply by to get a negative y? The answer is a negative 1 if you wanted to distribute it back out. So now we're almost done. Our last step to get y by itself will be to divide by x minus 1. Okay, so those will cancel, just leaving us with y. And since we know we have y by itself, that means that's our inverse function. And it will equal negative x minus 2 all over x minus 1. If you wanted to factor out a negative in the top, you could. This is an acceptable answer. But if you prefer, you can write it as negative x plus 2 divided by x minus 1. Because sometimes we don't like to have that leading term with a negative in front of it. That's just if you're getting picky. But like I said, what we have boxed is fine for your final answer.